I have no idea what just happened there. Okay, I have a vague idea. Um, YouTube has changed menus around, and my control menu was gone. I went and dug through 35 other menus. I was going to delete this stream and recreate it, but here we are. And it is a Monday. It's almost the end of March. So huzzah and welcome to ADRAMADA. ADRAMADA, another Dave Rush Ask Me Anything, Digital Alchemy. That's so dumb. You really got to fix that. But here we are. Hey, Jason's here. Patricia's here. Tullowit is here and has been for 4 hours or so with down internet. Yeah, you guys in Paradise, you've had a challenging week. I can't turn on the news without seeing 3 major things in the news, and y'all are one of them. Excuse me. Beg your pardon. All right. Well, let me see if I can get some of this done whilst I'm chatting. Do that. Do this. Sorry, I'm a little bit behind because of El Techno Glitcho. Give me a momento, and everything will get caught up. Zip, zip. It's been a very busy week for me as well. As some of you know, last week I was on the road for a couple of days. 2 days on the road doing gigs in 3 cities. And it was exhausting. Not because the gigs were particularly exhausting. They were all right. But a week ago, my AC compressor in the car committed suicide. So good news, I'm on a weight loss kick. That has really helped me lose a ton over that week. Yeah, close to a literal ton. Hey, all right. Well, we're here. I'm caught up now. Let's see what's going on with the notes. This is Monday, March 30th. So tomorrow is the big day, right? It's the end of our 31-day march. I know. March puns are my favorite, and I'll run out of them tomorrow. Don't want to do that. I feel out of sync today. How's that? And I have some cool things that I want to mention. All right, well, let's just do a little bit of newsy stuff because we do have a lot of stuff to get through. And man, I love today's project. I have been waiting literally for years to do today's presentation. It is, if I had my way, this would be a multi-hour presentation, at least 2, probably 3 or 4. But we're going to cram it in 30 minutes, and it'll still be walk away useful for you. So what's going on here? I have slides. So all right, let's bring some slides in. Go over here. There's the slide manager. By the way, I ordered this a couple of weeks ago. It still ain't here. But every day I get some kind of notification that it has moved in some direction. So we'll get there. It'll be a fun thing. I see a lot of people online telling me that they built it in about 45 minutes. My guess is I could build it in about 45 minutes, and then troubleshooting would take 3 hours. So as I mentioned, when I get it, I'm going to plan on taking the whole 4 or 5 days and doing 20-25% per day. We'll see what happens after that. Okay. Here's slides, just a couple to get things started. That's not what I want. That is. So today, on this date in history, again, today being March 30th, way back in 1856, this is just history, there's no tech in here. The Russian Empire, the Ottoman Empire, Great Britain, France, and the Kingdom of Sardinia signed the most famous treaty probably ever signed. There's a few of them that are real up there, but this one was to end the Crimean War. Yes, it was the Treaty of Paris. And what was that, 1856? So exactly 8 years later on the day, another lovely historical event. And that was known in the vernacular as Seward's Folly. Seward, in 1867, was the U.S. Secretary of State, and he orchestrated the purchase of Alaska for $7.2 million. And I don't know why I have this number, $109 million in 2018 dollars. So what? It's 8 years later. Couldn't have doubled then. So $200 million or so. That's whatever it was at the time. It was 2 cents an acre to purchase Alaska. Outside of the Louisiana purchase, or maybe on par with the Louisiana purchase, one of the greatest peaceful expansions of the U.S. And that's it for history. I only found 2 things that I found that I wanted to share with you. Good stuff, but nothing really cool. If you are new to ADRAMADA, you're watching this perhaps not live, or maybe you're watching live after the fact, this is not our only communication venue, and we invite you to participate in all of them. We have a very fun and interesting Discord server, the ADRAMADA Discord server. And if you look up at this time mark in the chat field, you will find the invite to that. And if you come here with the intent of spamming junk or whatever, Patricia has set up landmines for you that actually fly to your home and get dropped off. So don't do it. My contact info is in there if you ever need. My X account, you can chase me down on there. And nobody has ever chased me down on Mastodon, but I love the idea of Mastodon, so my Mastodon contact information is there. So I'm a little behind. We didn't do shows for the last couple of weeks because, oddly, I got Monday gigs. I don't usually get Monday gigs. But they were, and they're a real pain as far as the show goes. Last Monday's was, it doesn't matter. It was what it was. So when last we got together, I think that was March 9th or so, we talked about binary logic and the electronic circuits called gates used to execute their functions. We talked about things like buffers and AND gates and OR gates and NAND gates and NOR gates and exclusives. And it was all kind of cool. It was kind of theoretical, right? We gave you the basics, the academic version of it. And I mentioned back then that it would be cool if we could get into what makes them practical. And if you're in an electronics frame of mind, okay, that comes pretty quickly. But if you're not, that's why you're here today. We are going to advance the concept from the theoretical, from the academic, to a great real-world application. We're going to look at practical use of one of the gates, the XOR function, X for exclusive. And we're going to find out how XOR gates or algorithms, right? You don't have to use circuitry. We can use programmatic language and software. We're going to use the XOR function to encrypt and to decrypt data. If you're pursuing, Security Plus, or even Network Plus or CCNA, you've got to know a little bit about security. This is the heart of a tremendous amount of security-oriented functions. Not the only game in town, but it's a very good game. Let's see, do I have a slide for this? Yeah, switch back to slides. So everybody's getting geared up and excited for the launch of Artemis 2 about 2 hours ago or so. The official countdown started. The launch is slated for 2 days from now, April 1st. Now, I know, the joke writes itself. You write your own. It's too easy. I'm not doing it. But we'll see if it happens. There's been a lot of delays, and I got more things to talk about in there. And If you're new at this game, if you're new at the ADRAMADA game, go, yeah, landmines, all kinds of mines. Go to the Discord server, go visit it, and find my latest take. I have been a space nut since Armstrong walked on the moon. I was 6 years old at the time. Yes, I know, I'm old. But I'm going through a bit of a change. So, but I won't do that to you here now. Artemis 2 is going for a trip around the moon. He's going to launch. He's going to circle the Earth a couple of times, pick up some speed, head out for the moon, do one twist around there, come back, enter a semi-orbit, and splash down in the Pacific Ocean. I think that's the name of it. Didn't we do this? Didn't we do this before I was 6? Okay, you kind of get the feel where I'm at. Other topical stuff. That's all we should do. If you're a follower of basketball, we are in the middle of March Madness down to the Elite Eight. If you follow that, I hope your team is still in it. Well, after my teams, we were 3 that we were kind of following, 3.5, and they're all out now, so I no longer care. Remember, any tournament, and we'll stick with this one, March Madness, it takes 64 teams and it grinds them all away until only one remains. So your odds are low. And if your team is in it and they're in it this far, man, kudos to you. In the end, there can be only one. This is a short week for some of us. I would not be one of them. I will be in the full week. But for our government and for many other businesses and parts of the world, Friday is Good Friday. A lot of people are off that day. The stock market will be closed. And, of course, the following Sunday, Easter, the most joyous holiday of our year. Does it compete with Christmas? Okay, they're tied for what they happen. Wonderful, wonderful stuff. I have a new binge. I was in Austin at the end of last week. My kid lives in Austin. And every time I go, if we get together, it's usually long enough for a meal. But he was off on Friday, and I didn't have to go to my gig until 4 o'clock. So we got together, did lunch, did all that, came back to his place, and he played a game with me. He's a funny guy. I like him. You should, right? Some people don't like their kids, but they do love them. I like mine, and I love them. He casts this appearance that I'm too sophisticated for TV, and he works hard and he's smart and but then it's, have you seen this? Have you seen that? Have you? Yeah, some of this I have, some of them I've not. And he said, well, did you see this one? I said, no, you've mentioned it to me a couple of times. Really like it. You gotta watch it. Okay, well, I will when I get home. No, we're going to do it now. And he parked me in front of an episode. And I'm a little bit hooked. We came home and I shared that episode with the missus. And we watched number 2. I don't know. And after 2, I'm starting to get pattern feel from series. But it's The Pit, 2 T's. It's a very, very gritty look at an ER drama, starring Noah Wiley. And I'll tell you one thing about it. We're in 2026, right? And there have been medical shows since television has been on. They market these things to a certain demographic, and that demographic never, ever, ever goes away. So we can sell laundry detergent to that demographic. But while the shows have never gone away, they get more and more realistic as time goes on. So this one, when it comes to medical gore, they don't skimp. You can get gorier, and there will be in the next generation and the next generation, but it'll flip some of your stomachs. All right, let me see who's doing what, and then we'll get into regular real-world news. Let's see, go all the way back to the top. Here's a question, says Tullowit. If modems all go down in the area, when the cable internet starts coming up, do they queue modems requesting access by time? And would a power cycle manually drop you to last? I don't know what the negotiation process is in DOSIS. I think we're still on 3. I don't think we're in DOSIS 4. But that's something. And I wonder if Jason has any insight on that. If not, we need to find, that'd be kind of cool to get a DOSIS expert or a support or design expert. There's my new goal. Let's see what we can learn about that. My feeling is no, it's not access by time, or if it is, it happens so fast that who cares, and that there's so much schmaltz in the system that it can multitask very well. That's my theory, but it's just theory. Thank you for your prayers. They worked. As ever and always. All prayers are answered. Maybe not the way we want them, but they are all answered. Something I got from a pastor, I don't know, 3 decades ago, something like that. Okay, we're live. What's up, says Jason. There's all my links for people to come up. Landmines. Landmines, you say, like wild times. Let's see. Just thinking about you. Wow. There's a number of people here. I don't know. But I hope you're thinking about me. I was thinking about you. Oh, Joshua's here. Joshua? Oh, Joshua's here. Oh my gosh. Sorry. I saw the J and assumed Jason. Joshua. Kudos. Welcome, my friend. Must be messing with something in our area. The modem power levels keep changing. Yeah, well. Yeah. You know that other modem power levels in your area are changing, not just your own. That's not a thing. Xerxes, yes. Cooking dinner. So send me away. Okay. We had thin pork chops and sauerkraut. A few years ago, a German lady that I have known for many, many, many decades. I was over visiting her. She was not doing well. It was the last time I saw her. Wonderful, wonderful lady, came from Germany right after World War II. And myself and a compatriot were visiting her. And she says, "Do you want some sauerkraut?" And I said, "Sure." And this is new to me. I grew up on sauerkraut, out of jar, in oven, cook, walk away. And she served it, and she sprinkled, or she cooked it with what you guys already know, brown sugar on it. Oh my gosh, this is a whole new thing. And I came home and I made it a few times like that. But my wife, who also was raised on it the way I was, didn't see the appeal, and I haven't had it since. I remember eating dinner here myself. Okay. Dave, can you give a shout out to my Michael? How in the heck are you? We have you eternally on our prayer list. I understand you took a dive, and you've got leg challenges, right? I don't want to. Was that a HIPAA violation, Michael? We miss you. We hope you're seeing this, and whether or not you see this, know that we love you and that we are praying for you all the time. And same for Patricia. And I pray for you in particular, not just because of your injury, but because you're married to Patricia. I'm sorry. Patricia is, as you know, better than anybody, the most wonderful lady. What a wonderful person. 3.2 last, I remember. Okay. I don't think it has anything to do with dropping you to last. Okay. We have some insight into the thing. All right, let's go back to slides and do news of the day. Zip and zip. And zip and zip and zip. Okay. Oops, gotta highlight that. So I don't have a lot of news stories, but a few. And take that, for instance. What would you say if you were on the International Space Station and you encountered that? I didn't write down my news sources this week. I apologize. I had to do some slamming. A grotesque purple life form was photographed sprouting tentacles on the ISS, causing a stir online. It did not cause a stir in the ISS or at NASA. They know exactly what it is, and you will too in seconds. Last week, NASA astronaut Don Pettit shared a photo of this entity floating in the confines of the craft. It is deceiving. In reality, it's just a purple potato. Those are eyes. And because they have no gravity to guide them, they kind of spewed out like tentacles. What I love, they named this potato Sputnik. Because what I like about this story is not just that, but how it came to be. Don Pettit. Did I say Don? Yeah, Don Pettit. He is the oldest active astronaut, and while on his last long-duration mission back in 24 and 25, he decided to grow potatoes. I have 10 jokes that would go with that. Each of them would be a 20-minute story, and The Martian, of course, is way too obvious. I wouldn't even consider doing that one. But, sorry, all I envision is this old astronaut who's got nothing but a hobby left, and his hobby is growing potatoes. I've amused myself. 3.2. Okay. Doses. Next slide. Move on over to the slide advancer. Hey, there's one. This is an artist's conception of Gateway. Gateway is an orbiting space station that orbits the moon and is planned to be a stepping point for equipment and personnel drop-off to the moon, and a launch point for coming home, and a launch point for launching to the stars or to Mars. They killed it. Last Tuesday, I was watching this, and this is when my attitude at NASA turned. It's been turning for a while, but this one is a big hit for me. So what's going to happen? NASA will invest $20 billion to develop a base on the moon, and everything is going to have to go direct to the moon. We're not going to stop at a gateway. And the people and equipment that have been created will be repurposed for Moonbase. By the way, I love Moonbase Alpha, and I found a channel that shows it fairly regularly on stream. I never saw all of them. I still haven't seen all of them, but I'm really enjoying that. If I do park in the living room after a day of work, I'm going to surf and find Moonbase Alpha, Space 1999. I'm going to do that. I like this slide name. I've called this slide Polish. This is nowhere close to good. Every one of us has seen, and maybe some of you have, people who work on computers, or maybe even your own tablet or phone, and they have nails the size of a pterodactyl. They don't work on touchscreens. And so some enterprising person, organization, has created a nail polish that enables fingernails to work with touchscreens. And I just thought that was kind of cute, kind of cool. On your left is a glass of leftovers from making Kentucky bourbon. For every gallon of bourbon that they make, there are 6 gallons of waste product. And that waste product goes out as fertilizer. It goes out as animal feed. The chemistry that it is made of, if appropriately repurposed, has much greater value and much greater use than those two things. And so a grad student at University of Kentucky made some friends over there and did some research and started working on these leftovers. These leftovers are called stillage, by the way. Leftovers from the distillery, the still. And I want to talk to you for a second about a piece of electronics called a supercapacitor. A capacitor is kind of like a little battery, except it doesn't hold a charge very long. It holds a charge and then it lets it go. Holds a charge, then it lets it go. Slowly charges, slowly discharges, depending on its capacity. Well, supercapacitors are a different animal. You can charge up a supercapacitor super insanely fast in seconds, but it cannot release its charge slowly. It shoots out. It's lightning. Well, this grad student took some of this stillage and distilled it down to its carbon chemistry and made some supercapacitors out of the material there. And what we discovered is 2 things. One, there's 2 ways to make them. One is just regular good old-fashioned boring carbon. And they found that when they made supercapacitors out of that, they were about the same capacity and had similar properties as a conventional supercapacitor. So that's cool because you can now do that inexpensively. And when they used treated carbon from that, they treated it with a couple of different goodies. There we go. Called activated carbon, and activated electrodes could store up to 25 times the energy per kilogram as conventional. So maybe there's an interesting future there. 2 more news stories and then into our world. As you know, I DJ on the side. I use regular traditional DJ software, but I also always have my backup system, a little Raspberry Pi running some open source software called Mix. And I thought they were pretty well done with Mix. I haven't seen much development in a long time. Hey, it was in the news today. It's been updated. It's been upgraded. And I won't even go into all the details of that, but it's cool stuff. I think this is the last story. April's coming. April of an even year. And that means a long-term release, a long-term support release of Ubuntu will be out next month. Here is the first official beta for it. Came out today or yesterday. So if you are an Ubuntu user, I am, outside of Raspberry Pis, and I even have one Raspberry Pi running Ubuntu. Get ready for a new long-term release. I always debate real heavily as to whether or not I want to switch from my old, in this case, 2404 to 2604. Right, 2604, the year is 2026, the month is April. It uses the most current Linux kernel, Linux 7.0, and Genome 50. Oh, there is one more. TrueNAS. TrueNAS is an open source version of Linux that's used to manage storage spaces. And it's got all kinds of different storage file systems, from ZFS to Apple File Protocol to server message block, and lots of other goodies. Well, they kind of got bought out, and they bifurcated their products. There is an open source version, they call it a community version, and there's an enterprise version, which ain't free. And there's been a lot of talk right now about, will there continue to be a community version? And I'm not going to read all this nonsense. What they've said in what I've read leaves me concerned because they didn't speak very clearly in terms that would make those of us who like open source to give us the feel goods. They're calling it open source core. So I don't know what that means, but if you're TrueNAS users, be wary. All right, let me see what you guys are doing, and then we're going to get into La Projecta. Slow on down there. Man, I got things I want to talk about too, but I can't. I got to dive into the project. Might run a couple moments long. Won't be too long. Okay. I super scrolled while you guys were talking. You say the new Highlander movie is looking good. I didn't know there was a new Highlander movie. I skipped over that earlier. I apologize. All right, well, that'll give me something to look into. And, of course, we got the Godzilla movie coming out again, the sequel to +1, -1, whichever it is, in November. And there's another November release coming out. We got a Christmas gift from a good friend who gave us movie tickets. I am waiting until November to use those. Hey, yeah, sure, you betcha, Patricia. So in this type, current is 3-1. Okay. Well, the fact that we were in 3 makes me happy. So technically, I'm drinking to improve the environment. That was the tack I was going to take. There was never a good reason to stop drinking bourbon, and now we have yet another. Yes. Okay. Well, let's talk a little bit about XOR again. So we'll start with just a brief talk about encryption and decryption. You know what those terms mean. What's important is that we kind of put some blocks around these things. So I want to send encrypted data to somebody else, and when they get it, I want them to be able to decrypt it. So both sides need a locking mechanism, and both sides needs a key to open that lock. And that may be an algorithm, it may be a mechanical device, it may be an electronic circuit, whatever. And it seems obvious that the keys should be the same on both sides. But knowing most of you as I do, that's not always true. In fact, if you use a certificate system, like in a web server, the web server has a certificate, and that certificate comes with 2 keys. They're completely different numbers, but they are mathematically related. And so what happens is it designates one of them as the public key and one of them as the private key. The public key, it distributes all over the place. Anybody who comes in contact with the server, hey, here's my public key. But he always keeps his private key. And what happens is that when I get his public key, if I want to send safe data to him, I will use a common algorithm. Everybody can know the algorithm. That's okay. And I'll use his public key, and I will gen up an encrypted message. You cannot use that public key to decrypt the message. So all these people out there who have the same public key I do, they can't decrypt the message if they were to intercept it. So I'll send it back to the web server, and he uses his private key, completely different number or whatever combination of characters, and only that private key can decrypt the contents of what I encrypted with his public key. Now, if I want him to send me back encrypted information, then I have to have a key pair. And I send him my public key, and I keep my private key. And so whenever we're doing encrypted communications, I will always encrypt with that guy's public key, and he will always encrypt with my public key and send it back, and we'll each use our respective private keys. So that's when we use numbers that are different. But before that mathematical alchemy came into being, everybody needed the same key, and we just had to protect it or change it regularly or something like that. Let's see, did that. Well, let's go back, way back, briefly, to a world before computers. We had to move messages back and forth between leaders, between military commanders, and things like that. And we used analog encryption methods. One of the favorites of mine, I don't have one here. I was thinking about building one today, but I didn't. But take a tapered stick, nice and narrow at this end, nice and thick at this end, and now take a thin strip of paper and coil that paper around the tapered stick. And now write your message, kind of like a typewriter. And when you unwrap that, uncoil that, there's no way to make sense of those letters. The person, the receiver on the other end, has to use a tapered stick that has exactly the same length and taper as mine does. And he will coil it around, she will coil it around, and be able to read what I wrote. That's an analog encryption. Substitutions, those are analog encryption methods. But it's 2026. We use digital encryption. We can use software algorithms. We can use electronic circuit algorithms to implement a locking mechanism. And we use keys. Those keys might be strings of characters. They might never change unless I changed it and communicate that with somebody else. Or they might be really sophisticated and change all the time. Which leads us to our next thing. Whether we're using an analog encryption or a digital, if we're using same keys, I have to communicate that key that I have to somebody else. You do this all the time. You go into a restaurant and you fire up your phone and you have no phone service in there. And you say, hey, I see there's a Wi-Fi here with the restaurant name in it. Can you share the Wi-Fi password? Bingo, that's the key, the Wi-Fi password. And they will tell it to you, or they'll write it down for you. Or maybe it'll be buried in some other server that you have to go through a gateway to get to. Somehow we've got to do a key exchange, and the type of key exchange that we do depends on how secure we need things to be. Well, the algorithm we're going to talk about today is the XOR function, the exclusive OR function. We can implement it as a circuit. We can implement it as a gate that's in or on an integrated circuit. We can implement it as a software function. Well, why? What's so special about XOR? Well, XOR has an incredible magic property. And I don't think it was designed to do this, but somebody looked at it and said, hey, wow, check this out. With this single XOR algorithm, it can perform both encryption and decryption using the same key. And I'm going to show you exactly how that works in here. So let us review the XOR function. You go up there, you go up there. There, you go there, and this is the world's worst. No, that's not. But the world's worst drawing is coming up. So this is an XOR gate. X stands for exclusive. OR stands for OR. And what we do is we take two digital inputs, a 1 or a 0 into the A channel, a 1 or a 0 into the B channel, and the result comes out. A XORed with B. Now, to appreciate what's going on here, I'm not get ahead of myself here. It's too easy to do. I make a lot of slides. Ha! Let's try that again. There we go. When we talked about gates a couple weeks ago, we said that every kind of gate has a truth table. A truth table shows me with different inputs, all the possible different inputs, what the output would be. And if you just look at the first 3 of these, that's what you would have in an OR gate. And an OR gate, if we translate it to true English, we say, if either of the inputs is a 1, the output will be a 1. So looking at that first combination, the input on A is a 0, the input on B is a 0. So there's no 1s on either input. The output is a 0. Ooh, second one. There's a 1 on the A input. I don't really care in theory on an OR gate what happens after that, but there's a 0 on the B. But since one or the other is a 1, the output is a 1. And the same thing happens on the next row. Got a 0 input on the A input. I got a 1, yay, on a B, and that would be output. Now, if this were a true OR gate, the fourth line would be different than what you see here. And that's what the X does for us. We said that an exclusive version of a gate is one where you change the rules of the gate a little bit. So if it were an OR gate, 1 and 1, or 1 or 1, since either of them has a 1 in it, the result will be a 1. But an XOR says, nope, if you do 1 in both inputs, the output is a 0. Okay. So let's try an example here. I want to send a word from me to you. And the word I'm going to send is the word home in uppercase. Well, I can't send an H across a network. I've got to convert it into digital values. So I used an ASCII converter, and I looked at all of the values here for H and O and M and E, and you can read them here on the chart. We'll focus on this H. So he's 01001000. So that's the first thing that I'm going to wind up sending out. That's fair. So here we go. Now I guess I could, but we're missing a piece here. I can't just send a string of 8 bits and get what I want. For every time that I send a bit into A, it's not going to generate an output unless I also send a bit into B. This is my encryptor. Okay, I'm going to use this XOR gate as an encryptor. And what I'm going to do is I'm going to pick a channel. And I have selected A to be my clear text input channel. And I'm going to select B to be my key input channel. Move the slide. So I just invented a key. And it's just the word figure. F-I-G-U-R-E. And I converted that into binary using an ASCII converter. When I send the letter H with his 8 bits, I'm also going to use the F in figure with its 8 bits. So let's note him down, 0100. He kind of starts out the same as the H. They both start 0100, but then they end up a little differently. The H ends with 1000. This ends in 0110. All right. It doesn't matter in an XOR gate if I send the key in the A channel and the clear text in the B, or the other way around, because the output's going to be the same. Okay. Move it along. So here we go. I have just sent in all 8 bits. I'm working left to right of H on top and F on the bottom, and I've generated an output. Now let's look at that in terms of the truth table that I have shown down here underneath it. So the first bit in H is 0. That's going to go into the A channel. The first bit of F is 0. That's going to go into the B channel. And now I look at the truth table, and it says if A is 0 and B is 0, the output is 0. And that's what I have as the leftmost bit on the right side of the XOR gate. How about this second one? In both instances, the second character The second character of the H, the second character of the F is a 1. So I'm going to look down here on my truth table, and I'm going to find 1, 1, and oh, he's using the funky rules of XOR. It says 1 and 1. If it was an OR gate, that would have been a 1, right? But nope, it's an XOR gate, so 1 ORed with 1 is a 0. So the second character of the output is 0. And you do that for the other 6 characters, and we come up with an output of 0, 0, 0, 1, 1, 1, 0. Nobody can take that information and figure out what the original clear text is. They don't know what character that I used. And you're looking at that saying, wait, Dave, there's only 26 characters to try, or 52 if I use uppercase and lowercase, or 62 if I added 0 through 9, or a few more if I added some common punctuation. Fine, that's theoretically true. But I've got another trick up my sleeve that makes this a lot harder to come up with an answer. But let's remember this now. The output, the encrypted content, is 0000 1110. Off to my notes. Slide 25. Home XORed with figure. Okay. Repeat this. Now let's say that instead of the word, that's a bad example here. Not ready to talk about that. Let me slide over past that. But let me do this. Let's say that I'm sending out a phrase that says, home is the best place to be. And my key is really short and stupid. Figure. Well, HOME space IS. Oops, just the I. Home is with a space. I can use figure and XOR it with those first 6 characters of home is. But now when I get to the S in is, I'm out of key. So what you do when you run out of key, because this happens all the time, there's always more text than there is key, we cycle the key back around. So if nobody knows how big my key is, 1 character, 10 characters, 56 characters, 256 characters, 1024, 2048, right? That's why keys get bigger and bigger and bigger and bigger over time, because it gets a lot harder to try to figure out these incredibly long strings of keys if we want to hack. All right. So I've got this encrypted output, 0000 1110. What do I do with that? Well, I send it to my receiver. And what does my receiver do with it? Well, it's his job to decrypt it and find out what's going on. So he has an XOR gate or an XOR algorithm or whatever. He's got a machine. It's the same machine as mine. And I called him up on the phone or somehow otherwise communicated that the key is figure. And what he's going to do is he's going to take my encrypted text, and run it through the XOR engine exactly the same way I ran the clear text through there with the same key. So this is really cool. Let's look at the first bit of this encrypted text that came out, 0. And I'm going to XOR that with the first character, the first bit of an F. Okay, I got 0 and 0. I look at my truth table, 0 and 0. On the right-hand side, first character is a 0. How about the second character of the encrypted text? It's a 0. Second character of the key is a 1. I look for 0, 1 in my truth table. It's in the second row. 0 and 1 are a 1. So that becomes the second output bit. And if you do that 8 total times, with the encrypted text and the 8 bits that make up an F, you're going to come up with 0100 1000, which is an H. And now I'll do that again with the encrypted text that made up O, and again with M, and again with E. Each time using more of a longer encryption key or cycling shorter encryption keys. That's it. That's the magic. I can use this one little algorithm, this one little circuit, to encrypt and decrypt the same thing. So why do I care about this? Well, the system is simple, but it's still at the heart of a huge number of digital encryption services. Yeah, there's more sophisticated systems out there. Probably the big guy right now that has commercial usage is ECC, elliptical, I think, but it might be elliptic, curve cryptography. Elliptic curve cryptography, yeah. But we don't use XOR internally at the core of most encryption or things. Let me try that again. We don't use XOR at the core of ECC, but it is at the core of many other things. And now look at the magic here. How about I XOR something with key number 1, and then I take that encrypted output and I XOR it again with a different key, and again and again and again. I can undo those all in reverse order using XOR as long as I know all of those keys and the order that they were used in. So that's one of the ways that they foil hackers. We call that salting, right? When I change up, or if I start out by taking my data and pre-encrypt it with some key, now it's salted. And you can do multiple salts before you ever get down to the primary machine and start doing the real job. Hey, what do you think, huh? Is that slick or is that slick? Let me check and see what you talked about, and we're going to wind up the show and figure out a good show for next week. 3, 2, 3, 1, bourbon. Oh, bourbon. Now I'm looking for words that rhyme with bourbon that Tullowit might have been teasing that he was thinking of. Okay, everybody's there. Cool. Okay, no new changes. You didn't talk about nothing. This is the heart of Chapter 2 of a cryptography course if I were to write one. Okay, we would talk about analog cryptography, and we would talk about Visionaire's crypto systems and all of that. Well, who doesn't love bourbon? Goodness gracious. Unless you prefer Scotch or Irish whiskey. I like them all. I can't have much anymore. The Writing on the Tube. Never heard of that, but it was a good start there. Thanks. Okay, guys. Thank you so ever much for joining us. I have no Monday gig so far next week. I don't know what next week's topic is. You got any ideas? Send me some. Otherwise, in the next day or so, I will go through my list of ideas and start working on a newbie. Hey, let's fire this thing up a minute and a half early for a change. Anybody else have any thoughts here on the show? Thanks. Me too. I like crypto. I threw this to my old boss a long time ago that we should do this, and he agreed, but we never did it. So I finally, yay, got this one under my belt. Well, guys, thanks. We'll do this again or so in a week. I wish you a great rest of the week. Take care of each other. Take serious steps to stay healthy. And if at all possible, call or visit your parents. And if it's not possible, your sibs, your kids, your nieces, your nephews, somebody you love, especially if it's somebody you haven't done that in a while. Never forget, technology is great, but the greatest resource we have are you and I. And with that, I bid you good night. I'll see you on ADRAMADA next Monday and on the other platforms I'm on. Until then, remember, how you do anything is how you do everything. Eep, up, or ah.